If we want to study the effect of one or more variables on a continuous or ordinal outcome, we could use linear regression, ANOVA, or Kruskal Wallis test. And the name of the function for the linear regression is LM, linear model. And if you want to do a univariable regression and look at the dose as a function of the age, you do like this. Firstly, we read in the warfarin dataset, and then we just write LM. First, we give the continuous variable we want to use. It's $dose. And then what variables we would like to have in our model. And in this case, it's only $age. And then we get this result. We see the formula, and we get the intercept and the coefficient for the age. And it's minus 0.4468. So the dose a patient has would be 64.444 minus, and then this value times the age in years. So we can conclude that the dose decreases by 0.4468 milligrams per week per year. We could also have written like this, LM, and then just dose for the dose column over tilde age. And then we could add data equals D. And this is useful if you are doing multivariable regression. And as for the other statistics methods, we could get more detailed results if we save our linear regression as an object. So in this case, we save it in the object R, and then we put our linear regression here, and then we write summary R, and then it will look like this. We get the formula, we get the residuals, and we get the coefficients. Here is the intercept, here is the age, the standard error, the t-value, and here we have the p-values. And these are really, really significant. And here you can see the degrees of freedom, the R-squared value, and the adjusted R-squared value. If you want to extract values from the regression, it can be a bit tricky. If you would like to have the coefficients for the age, you would need to write like this: summary R $coefficients, and then 2, because if you look here, you could see this as a table, and this is the second row and then the first column, so you will get the estimate here. So here you have the value. If you would like the standard error, you would instead write summary R coefficients 2, 2, and then you will get the standard error. And the p-value was in the 4th position of this result table. So if you want it, you could write summary R coefficients 2, 4, and then you will get the p-value. And here you will get the more exact p-value than you in the table. If you want the confidence intervals, you need to write conf int, and then which object R, where we have put our regression, and then 2 for the second line. And then we also tell the level that we want a 95% confidence interval. And then we get $age, and we get this lower confidence interval and the higher. If you want to study your model, it's easy to do diagnostic plots of your linear model. You just write plot R. Then you get all these 4 graphs. The residuals versus the fitted, normal quantile plot, scale location, residuals versus leverage. So here you can see if they were like normally distributed, if the bell shape of the population was normal or not. In this one you can see if you have some specific value that is influencing your results a lot. Here is an example if you want to do a multivariable regression. In this case, we look at warfarin dose as a function of age, gender, CYP2C9 genotype, and BRCA1 genotype. So we put this in the object R, where we put this linear model, and here we have dose, which is the column with the continuous variable we want to study. And then we write over the tilde sign, age plus sex plus CYP2C9.2 plus CYP2C9.3 plus weak course C1.A, and here we write data equal D. And then if we write summary R, we get this result, we get the formula, the residuals, and then we get the estimates for all this for age. We have this minus 0.449, which is almost the same as in the univariate model. we get that male gender increases the warfarin dose by 3.7 milligrams per week. That having one mutated allele in CYP2C9 star 3 will give 5.6 milligrams less per week. And if you have one mutated CYP2C9 star 3 allele, you will have 11.4 milligram less. And then we have VECRO C1A, where also one mutation will lead to around 11 milligrams less warfarin per week. And here you can see that all these were really, really significant. And here you get the R-squared value, meaning that these variables that we have put into our model would explain around 55% of the variations in warfarin dose. If you in your multivariate model would like to have an interaction between two variables, you should write, for example, age star 6, and then you will get an interaction between age and 6 also in the analysis. So this will give you the result if the effect of age differ between sexes. If you want to do a weighted linear regression, you could you add the argument weights to give different weights to specific data points.